Welcome back. Our lesson today is going to pick up where we've been previously with matrices. Prior to now, we've talked about adding and subtracting and multiplying matrices, and then we looked at even finding determinants and inverses. And when we talked about inverses, we mentioned that inverse could be used as a means of doing what we would consider division with matrices. So we don't really necessarily divide with matrices. However, we will multiply inverses to do the same thing, basically. What is that good for? Well, one thing we can do with it is solve what we call a matrix equation. Matrix equations are basically a method of applying just a regular equation to solve with matrices. And we might do this to solve a system of equations, among other things. And that's what we'll be looking at today, is matrix equations as a way of solving a system. So let's take a look at how this actually works and what a matrix equation is going to actually look like. So say we have a system of equations here with two variables, 2x plus 3y equals negative 17, x minus y equals 4. We can take this equation, or this system of equations, and write it into a matrix equation by using the coefficients 2, 3, 1, and negative 1, and putting them into a matrix. That matrix will be multiplied by the matrix xy. Now, since these two equations equal out to be negative 17 and 4, we'll say that they are equal to the 2 by 1 matrix, negative 17 and 4. So at that point, we would then solve the equation using inverses. But before I get into that, let me show you exactly how this is going to look and what we want to do here. If we were to take, for instance, these two matrices and multiply them, we would take this row times this column, and we would add the pieces that we got. This products would add together. So that would be 2 times x plus 3 times y. And, of course, this is a 2 by 2. This is a 2 by 1. They can multiply together because these numbers are the same. And our answer will be 2 by 1. So we're going to have a 2 by 1 matrix over here. That is the first row, 2x plus 3y, and then we would take the next row of the first matrix and multiply it times this column. So that would give us 1x, and negative 1 times y would be minus y. So that would give us the second number. So basically what we're doing is we're just taking the system of equations that we have, and we're writing it as a multiplication problem between two matrices. And like I'm showing you here, if you were to multiply them back out, you would see that it would give you the same matrix, or the same system of equations that we were started with. So that's said, let's take a look at this example and how we would solve this system as a matrix equation. Now, we've talked about how to solve equations, obviously, and if we're multiplying two things times the variables to get our answer, we could get this this matrix out of here off of this side of the equation by dividing, which is the opposite of multiplication. But we don't divide. What we do is we multiply the inverse. So I'm going to find the inverse of this matrix here and multiply it to both sides of the equation. This is my strategy that I'll be using. So the first things first, we got to find the inverse. So we'll go back to that. We multiply 2 times negative 1 and subtract 1 times 3. So that would be negative 2 minus 3 is going to give us negative 5 as the determinant. And then we will switch the 2 and negative 1 around and change the signs on 1 and 3. So we get this negative 1/5 times this matrix here, which is the inverse. Now, if I do this on one side of the equation, obviously we have to come over here and do it on the other side of the equation as well. Now, when I do this, I'm going to go ahead and save some time and multiply my scalar through. So I multiply negative 1/5 to all the terms in the matrix, and this gives me positive 1/5, positive 3/5, negative 1, or positive 1/5, and negative 2/5. So this is our inverse after we multiply the scalar of negative 1/5 through. Now we're going to take this and we're going to multiply it times the negative 17 and 4 matrix. That's 2 by 1 matrix. So when we do this, first off, on the left side, as I multiply the inverse times its own matrix, when we multiply two matrices that are inverses of one another, you'll remember we're left with the identity matrix. And that's basically like having just xy here. When we multiply this inverse times negative 17, 4, we're going to get this row times this column is going to give me negative 17/5. 3/5 times 4 will give me positive 12/5. So I get negative 17/5 plus 12/5. I know some of you don't like fractions. Don't worry, it's going to work out. 1/5 and negative 2/5, this row here, times negative 17/4 will give us negative 17/5 and negative 8/5. So when we combine all of these, negative 17/5 plus 12/5 is 5/5, which is 1. And negative 17/5 minus 8/5 is negative 25/5, which is 5. So on this side of the equation, we're left with xy. On this, everything here is going to simplify down to be negative 1 and 5, negative 5. So what I learn is that x is equal to negative 1 and y is equal to negative 5. And we have solved the matrix equation. Let's continue along with another example. So the first thing we're going to want to do is take this and write a matrix equation with it. And you'll remember we just take the coefficients and form a matrix. We multiply it times the matrix xy with our variables. And then we put what those equations are equal to in the other side as a 2 by 1 matrix. So we have this equation. We're going to want to get the 3, negative 5, 1, 2, this 2 by 2 matrix off of this side. So we're going to want to multiply its inverse. So let's take a moment and think about what the inverse would be. If we multiply 3 times 2, that's 6, minus 1 times negative 5. So that's going to give me 11 as the determinant. And we will take that, put it under 1, 1/11th, and we'll switch the 2 and 3 around. And we'll change the sign on 1 and negative 5 to be negative 1 and positive 5. And that's going to give us our inverse. So we multiply the inverse on the left side, and I'm also going to multiply it on the right side of the equal sign as well. And again, as I do that, I'm going to multiply through by 1/11th to everything. So I get this matrix: 2/11ths, 5/11ths, negative 1/11th, 3/11ths. So when we do this on the left side of the equation, hopefully you're seeing now that we would take the, as we multiply these two matrices together, since they're inverses of one another, they will leave the identity matrix behind. And then we're going to get, when we multiply 2/11ths and 5/11ths times this, that would be 36/11ths minus 25/11ths, and negative 18/11ths minus 15/11ths. 36 minus 25 is 11, so that gives us 11/11ths, which is going to be 1. And then we have negative 18 minus negative 15, or minus 15 would be negative 33/11ths, which would be negative 3. So our solution is that x is equal to 1 and y is equal to 3, or excuse me, negative 3. Okay, so that said, let's take a look at a couple more problems that we'll kind of do together, and I'll lead you through. Let me clear out this a little bit, get everything set up on our screen here. Okay, so we have our equation, or system of equations, is 2x plus 5y equals 31, and x plus 2y equals 13. So we will start off by setting up a matrix equation here. So we'll just take our coefficients, 2, 5, 1, and 2. And we're going to multiply that. Let's do something here. Okay, we'll take that matrix, we'll multiply it by x, y. And that is going to be equal to the 2 by 1 matrix of 31 and 13. Now you'll see I just left a little space there because hopefully by now you see what I'm going to be doing, and I just kind of left myself a little space for doing that. So we're going to go ahead and multiply the inverse of this 2, 5, 1, 2, and we'll start off by finding the determinant. Our determinant here is going to be equal to 4 minus 5, so that would be negative 1. So we will have negative 1 over 1, and we switch the matrix around. The 2's switch, that doesn't really change much, and then we change the signs on 1 and 5. So we have this. Excuse me. So when I multiply this matrix over here, I'm going to go ahead and just multiply through by this negative 1 on the outside. So I have negative 2, positive 5, positive 1, and negative 2. All right, so when we multiply this on the left side, we're going to get the identity matrix times xy, which of course works out to be just xy. And then I get a 2 by 1 matrix over here. So when we take this row, negative 2, 5, times this column, that would be negative 62 plus 65. And then we take this row times this column again, so that would be 31 minus 26. So we finish up, create a little more room here. We finish up with xy equals negative 62 plus 65 is 3. And we get that 31 minus 26 is 5. So our solution is x is 3, y is 5. All right, let's look at one last example. And here it is, 5x minus 4y equals 28. 3x minus 3y equals 18. So again, we'll set up our matrix equation. So we have 5, negative 4, 3, negative 3 times xy is equal to, I'll come over here, leave some space, 28, 18. All right, so we'll find our inverse, and hopefully you're seeing the pattern here, and we're getting pretty good at this. Our determinant will be the first thing I'd want to recognize. The determinant here is negative 15 minus negative 12, so that's going to be negative 3. Got my signs mixed up. Okay, so when we have this, that'll be negative 1/3, and we multiply. The inverse is going to be, when we switch this around, we'll have negative 3 here. We'll have 5 here. We'll change the sign on this 3 and change the sign on negative 4. So coming over here, I'll multiply the negative 1/3 through for the sake of making it a little simpler. This is going to be, positive 1. This would be negative 4/3. This is going to be positive 1 again, and negative 5/3. Okay, so we're going to get into multiplying this out now. So when we multiply this on the bottom, we're going to get the identity matrix on the left side. Times xy is equal to, that'll be a 2 by 1 matrix, 1 times 20, or we take 1 times 28 and negative 4/3 times 18. So that'll be 28 minus 4/3 times 18 is 72/3, which is 24. And then we will go to the next row times this column. So that'd be 1 times 28 again. And negative 5/3 times 18 simplifies to negative 30. So our final answer, I'll just kind of write it over here to the side, would be xy is equal to 4, and 28 minus 30 is negative 2. So we get 4, negative 2 for our solution. Okay, so we've seen a few examples of how to do this, and hopefully you're getting a good solid grasp on working with inverses and how they work together. And again, this is just one of the methods that we can use to solve a system of equations. Obviously, we've talked about some others, and there are many other applications for inverse matrices as well. We've looked at a couple in class already, and we'll be looking at some more this week in class. So hope to see you there, and if you're having any questions, we can address them at that time. Have a good day.